Hey,
Hello.
we're going to name some hydrocarbons with branches.
Branches like coming up the side.
Yeah, and we got to have a nomenclature system for it, but it's a robust system that we're just building on.
Right. So this is just another deviation from a regular alkane.
Right.
And these branches or substituents are made up of some number of carbons. We keep it to what, one and two?
1 and 2, pretty much.
Yeah. Attached to that parent chain.
Mhm.
What on earth is a parent chain?
Well, that's the backbone. It's the longest chain possible as you're counting. So as your molecules branch out and get bigger, you're going to have to count and try and find the longest chain within the molecule and use that as your parent. And anything else hanging off that is considered a branch.
Right.
That's what's up.
Yeah, basically, the rule is without picking up your pencil.
Yeah.
Right?
And so if multiple bonds are in the parent chain, so like if you've got branches and double and triple bonds coming up, the way that we do it is we always name our branches first. They're going to be at the first part of the molecule's name.
Right. And then we'll put a number in with an address of where the multiple bond is in the actual parent chain piece of the name.
Because the piece, that part of the name tells you if it's got an ene or an ine, an alkene or an alkyne, a double or a triple bond, the number needs to be close to the end of that. So we're going to see in this example down here, numbers showing up in different places, and maybe some commas and stuff, but we'll show you.
Right. So just like normal, the prefix tells us how many carbons in
Yep.
the parent chain.
Mm-hmm.
The root is going to tell us what kind of bonding is present in the parent chain.
Yep.
The nice thing about the branches is they have to be single bonded on, right? And then we need the side chains like a parent chain.
Mhm.
We're going to remove the ane and end with an ill, a YL.
So for example, a chain that is 1 carbon long won't be methane, it'll be methyl.
There you go.
A chain that is 2 carbons long will be propyl, not propane. 3 carbons?
Propyl,
Oh, I misspoke it. Ethyl. So methyl,
ethyl,
ethyl,
propyl.
butyl, penyl,
Yep.
hexyl.
So
we're
when
not
you
going
see
on.
that YL in a name, that's your clue. Look, that's different from the alkane naming system. What's different?
Means that there's a branch on the
There we
chain
go.
somewhere.
And the number in front tells us the important features of both. In this case, for the first few, just where the side chain is, and then the second piece would be
If
where
there's a
there's
side
a
chain and a double bond. I think
Mhm.
we only had one
build
example
now.
of that.
Build now. Got to do it. Remember, still numbering always defaults to the lowest number.
Yep.
And I think, this is where the double bond would trump.
Yes.
That's where the double bond would trump.
Right.
We go by the lowest number where the double or triple bond is.
I think there's just one example of it.
Right. So, my turn, or are you going back to?
I like you drawing.
All right. I like you drawing. So, I see 2-methylbutane. So, first things first, we need to do it just like before. Butane. That's what we need. So, I see 4 carbons for but, and then ane tells me that they're single bonded. So, let's do that.
Yep.
And then it says methyl. The YL tells me it's a side chain.
Yep.
Meth tells me it's a 1 carbon side chain. The 2 tells me on the second carbon. So on the second carbon, let's put another carbon. That's it. Fill it up with hydrogens and we done. You actually got to put the hydrogens down.
I'm gonna. You just keep talking.
Okay, I'll keep talking. So now we can figure out our molecular formula by the number of carbons and the number of hydrogens we have. Unfortunately, the series for general formula for the homologous series, this doesn't work here.
Not
because
anymore.
side chains deviate too far from that, so that math is not simple anymore. It is all single bonded, so it is saturated. It's holding as many carbons.
This one does fit the profile for the homologous series, by the way.
This one that we're doing,
C5H12. CnH2n
well, just
plus
because
2
it does fit doesn't mean it
will always fit.
correct.
That's what Mr. Milks was saying.
Yes. All right, so let's name this thing longest side chain. So if we go all the way across, we're going to get 5. And if we go in the bend, we're going to get 5. So that's it. We're going to start with 5. So that's a pent. And I see that all of the carbons are single bonded. So that is pentane. And I would advise if you can go bent or unbent, choose the unbent to make life easy,
Oh, yes.
right? So let's go ahead and circle that side chain because that'll help us then, right? So I have pentane. Now I have a side chain with 2 carbons. 2 carbons is eth, and we're going to take ethane and turn it to ethyl. So that's going to be ethyl. And then we need a location. And either way I count that side or the parent chain, it's on the 3rd carbon. If I count it from right to left, instead of left to right, it's still on the 3rd carbon. So this is 3-ethyl pentane. The 3 in front of the ethyl is telling you where the side chain is. Cool with that? Good. and counting up the number of hydrogens. While he's counting, I will tell you that it's all single bonded, so we know it is saturated.
And this also, again, fits the profile for the homologous series
True.
alkanes.
Does.
General formula.
It does. All right, now we have longest chain, counting right down the middle. I got 1, 2, 3, 4, 5. If I start on the left and make a turn, I only get 3. If I start on the left and make a turn, I only get 4.
No.
If I start on the right and make a turn, I can get 4. And if I start on the right and make the turn again, I can get 5, but I can't beat the 5 that's just straight.
Right.
So let's keep it there.
So
We can go ahead and 5 is pent. It is all single bonded, so it's pentane. Now let's circle up those side chains so we can see. Good. I have 1 carbon side chains, but I have 2 of them.
Yep.
Okay, so this is going to be complicated. They are both methyls.
Mm-hmm.
Okay. Methyl, but I have 2 methyls, so we're going to say dimethyl. And then guess what? The address is 2, 3. There's 1 on the second carbon and 1 on the third carbon, because if I counted from the right, it would be 3, 4 dimethyl, and we want to default to the lowest number possible. So it's 2, 3 dimethyl pentane. And of course, we're saturated because we're single bonds. Okay. Okay. Hexane, 6. 6 carbons, single bonded. It's easier to go this way from the name to the structure. It's faster. Okay. And on the third carbon, there's going to be a methyl group, which is 1 carbon side chain. Fill it up with hydrogens, and we're done. See, it's easier to draw them from the name than name them from the drawing, but we need to be able to do both. Need to be able to do both. And of course, it's saturated because it is all single bonded.
Gosh, I got to put all these H's in.
You got to put all those H's in.
Oh.
And notice, this is a good way of leading into the next video, by the way. See how it's C7H16 and C7H16 and C7H16. Notice those are the same molecular formulas with different structures and different names. That's a little pre-shadowing into the next video. Okay, how's that for you?
Yeah.
Same but different.
Same, but different, but still the same.
Yeah, you got any questions?
I don't know. I don't.
Well, oh, yeah.
Got more examples to do, though,
We got more
Milty.
examples. Okay. First one we're not doing because there's nothing there. I don't see anything there to help us.
Oops.
Yeah, so, we're not that all. No, not yet. All right, structural. 1, 2, 3, 4, 5 carbons is pent. But oops, I see a triple bond in there on the second carbon. So that is 2 pentyne. And I want to put the 2 in front of the pentyne because that 2 now talks about the yne. Cool with that? Oh, and that's it. There's no side chain.
Nope.
This one, though, this has both. Ouchers. 1, 2, 3, 4, and either way it's 4, right? But we need the the parent chain that has the double bond in it. So bute is 4. On the first carbon, there is a double bond, so that is the butene. Notice how we did that piece first. Now I have a methyl group, which is 1 carbon, side chain, so that's methyl, and it's on the second carbon of the parent backbone, so that's why it's 2 methyl, 1 butene. And because it is an ene, it is unsaturated. 4 methyl, 2 hexyne. Hex, 6 carbons. Yne tells me there's a triple bond. The 2 in front tells me it's on the second carbon. See how that works? Now on the 4th carbon, we have a 1 carbon side chain.
Good.
And this is a good example of what we talked about earlier, where the triple bond trumps as far as the naming system goes. Because if I started counting on the right-hand side and went left, this whole thing would look a lot different as far as the naming structure. So that's why we always have the double or triple bond in the parent chain trump as far as numbering system goes. Okay. And because there's a triple bond, we are unsaturated.
Yeah.
You got
I
it.
circled the wrong spot.
That's okay. And I guess what? We are, I think, lots of practice. Notice how we got to go both ways. We need lots of practice. See you guys in class.
See you.